Saludos cordiales a toda la audiencia del día de hoy, viernes 11 de octubre del 2024. Bienvenidos de nuevo a la sección técnica de los viernes en su segunda semana como parte de la programación de las terceras jornadas de Ingeniería Geodésica Aplicada, las cuales se realizan bajo los auspicios de SIGGMA, la Sociedad de Ingenieros Geodestas, Geomáticos y Agrimensores de Venezuela, y dentro del marco de la celebración del cuarto aniversario de su fundación. Les habla el ingeniero geodesta Alexander González, miembro de la Junta Directiva de SIGGMA, y quien tendrá el placer de moderar este webinar, el cual tratará sobre lo nuevo en Global Mapper Pro, una aplicación de Blue Marble Geographics. Tal y como fue anunciado por todos los medios de difusión, la sesión del día de hoy será en el idioma de inglés. Así que, a partir de este momento, continuaremos con la introducción de la presentadora en dicho idioma. Hello everyone, welcome to the third conference on Applied Geodesic Engineering 2024, hosted by the Society of Geodetic Engineers, Geomatics and Surveyors of Venezuela, SIGGMA. This event is being organized in commemoration of the 4th anniversary of SIGGMA. My name is Alexander Gonzalez, and I will be the moderator for today's session. As it has been widely promoted, this month-long series of free online events will feature technical discussion on cutting-edge topics in remote sensing, photogrammetry, geospatial technologies, civil engineering, artificial intelligence, and advanced geodesy, and they will be held every Friday and Saturday of October. On behalf of the organizing committee, I would like to thank you all for taking this time to attend this webinar, named What is New in Global Mapper Pro, which will be presented by Mackenzie from Blue Marble Geographics. Welcome, Mackenzie. As a matter of introduction, Mackenzie is an associate product manager at Blue Marble Geographics, a GIS and geodetic software company based in Maine, USA. Mackenzie worked across the company to drive the development of Blue Marble products, including Global Mapper Mobile and GeoCalc Online. She also provides technical and training and technical support to customers while also leading technical demos. Mackenzie has been with the company since 2018, and she is a graduate of Virginia Tech. For any comments or question you may have during her presentation, there will be a Q&A section at the end. Please feel free to write them down in the question section on this platform, and if the time allows us, she will try to answer them accordingly. With great pleasure, I want to welcome to our speaker, Mackenzie Neal, and thank her and her company for joining us today. Mackenzie, all the microphones are yours.
Hey, thank you so much for having me to present here and for the lovely introduction. As noted, my name is Mackenzie Mills, and I am a product manager, an associate product manager here at Blue Marble Geographics. I will go ahead and share my screen here, and we'll get going talking about Global Mapper Pro. Global Mapper Pro is one of our main products here from Blue Marble Geographics, and we will talk a little bit about the Global Mapper family of products and what the new version 26 that we released just about a month ago, offers to customers some of the exciting features and look at some data and the interface of the program as well. So to start off, just a little bit about Global Mapper. So Global Mapper is sort of the base version of our Global Mapper Pro program. It is a cutting-edge software that provides geospatial tools to users at any level. A lot of terrain analysis, vector data creation, and editing can be done in Global Mapper. And there are many different ways to visualize that data as well. Screenshot on this slide, we can see we're looking at a 2D view of some terrain data with contour lines. And then we can also see an oblique view of that data in 3D. If you're looking to unlock some more advanced tools in Global Mapper, that would be where Global Mapper Pro comes in. So this is sort of the next tier up, the next level of the Global Mapper program. And this expands on the functionality of Global Mapper and provides additional tools for advanced analysis, for advanced terrain analysis, and a lot of tools for point cloud or LiDAR data processing. So, we all are aware that, folks are able to fly drones or collect aerial LiDAR data and create those 3D point clouds, bring them into geospatial software in order to process them and create derivative layers and products. Global Mapper Pro has a whole suite of tools for doing that, and we'll get into some examples of those tools later in the presentation. The last product that we'll be talking about here also is part of Global Mapper, and it is the Global Mapper Insight and Learning Engine. This is the most recent addition to Global Mapper. It is actually in beta testing for Global Mapper Pro users in the just released version 26. And the Insight and Learning Engine is a set of deep learning tools that are geared towards image detection and object detection and image classification at this point. So with the Insight and Learning Engine, we have 3 models that we ship that are 2 for object detection, for building extraction and vehicle detection, and then 1 for full image classification, which would be land cover classification. This module to Global Mapper with these more advanced image analysis tools does include not only the detection of these objects and the classification of images, but the fine-tuning and editing of any models so that you can customize the processing to the data that you currently have. So just a quick overview of what we're going to talk about during this session. I'll start by pulling off a few key points of Global Mapper, which are our extensive file format support and our data visualization options. We'll then move into some of those more advanced tools and start looking at some data as we go through here. We'll talk about Pixels to Points, which is our tool for creating point clouds and stitched images out of drone or UAV collected images. We'll talk about point cloud classification, some advanced methods we have for that in Global Mapper Pro, additionally with the option to create a custom classification. We'll touch on terrain creation and analysis, because typically once you're working with your point cloud, you've classified it, added more information to it through some of these post processes. You want to create some terrain and some derivative products from that. And then lastly, we'll take a look at the Insight and Learning Engine with our deep learning image analysis tools. So this is not at all, the full scope of Global Mapper, but these are just some of the more advanced and then very exciting data processing tools. As I noted, Global Mapper Pro is a full geospatial software, so you can do vector data creation, vector data editing, in addition to all of these more advanced analysis processes. So starting off with file formats and data visualization. Global Mapper has an extensive file format support. Over 300 file formats are supported. So this means that pretty much any geospatial data that you have, you can load it into the Global Mapper program. That's great because it allows you to combine data layers, view them together, view all of these georeferenced data layers from different sources, all in one interface, maybe combining some information there. It also allows you to do file transformations. So you can load a file in from one maybe more obscure format and export it to a more common format that you might need to utilize in another program. We do have many users of Global Mapper that use the program for this extensive file format support, and that is its place in their workflow. They need to do some data conversion, and Global Mapper is a great tool for that at a very basic level. We also have an option to connect to online data in Global Mapper, so that is to directly stream image data primarily from available web services into the Global Mapper program. So if you don't have layers on a shared or local drive, but of an online source that serves up web tiles, you can stream that data directly into Global Mapper. We have a whole library of built-in data sources, as well as the ability to add custom data sources. So whether those are just data sources that are publicly available that you know about, but we don't happen to know about, or something created by your organization that is served as web tiles, you can stream that into Global Mapper and then perform any exports, analysis, and other processes on that data. Data visualization is another great asset to the Global Mapper program. Global Mapper offers 3 main viewers. We've got the classic top-down 2D view of a map. So that's our screenshot to the farthest left on this screen here. We're looking at some imagery that has had some shading applied to it from some terrain data. And we're just looking at a classic top-down view. It's a great way to visualize data, but the 3D and cross-sectional data viewing tools in Global Mapper definitely have their place when working with 3D data specifically. Our middle screenshot that's sort of hiding behind our main 2D view here is a screenshot from our 3D viewer. Here we have some terrain data, some extruded 3D building features, as well as contour lines. All this data is displayed together in the 3D viewer, and it gives us a better sense of the elevation change and the shape of the terrain in this area. It's a great way to explore 3D terrain grids like this and point clouds as well. The screenshot all the way to the right is our path profile view, or our cross-sectional data viewer. This is a tool where you will draw a line across some 3D data, whether that is a terrain layer, a digital elevation model, or some point cloud data, and you're able to see the change in elevation along that drawn path. So it's just yet another way to explore 3D data, do some analysis on it, and better familiarize yourself with the area of study for whatever project you're working on. So we'll be taking a look at some of those visualization options, as we get into the Global Mapper program with some of these additional topics I have here. We'll next move on to the Pixels to Points tool. Now, I mentioned this earlier. This is Global Mapper's tool for generating 3D point cloud data from geotagged, drone, or UAV collected images. So the Pixels to Points tool takes as an input those collected, captured, geotagged images, typically captured from a drone, and uses the structure from motion process to generate a point cloud, and from there can generate an image and a 3D textured mesh layer. All that is needed to run this tool is a set of overlapping geotagged images. Although there is a tool in the Pixels to Points workflow to incorporate some surveyed ground control points. Ground control is very important to any GIS project. We want to make sure that our data is accurately placed, and typically, especially when you're working with maybe a more affordable, easily available drone, some of the elevation measures tend to be a little bit off. So incorporating some surveyed ground control points can increase the accuracy of the generated point cloud and other outputs from the data. A little bit more about that ground control placement. We've done some work in Global Mapper Pro and the Pixels to Points tool to improve the placement of ground control points. We've got just a little screenshot of the interface here where I've loaded in some ground control points. I have some images displayed, and Global Mapper now has the ability to automatically identify and place ground control points. All the user needs to do to begin this process is find one image where that specific control point location is visually clear and identify or define the target in that one image. Global Mapper will then search through the rest of the images and place that ground control point accordingly. Now, to do this, of course, we're using some image analysis, some pixel matching there, but the Global Mapper program is also taking advantage of the image coverage polygons calculated from the camera parameters combined with the coordinate location of the control points to determine, where, in what images this control point is likely to appear, and then to sort of narrow down the area where we're doing that pixel image analysis to identify and place these ground control points. So before we move on to point cloud classification, I'm going to pop open Global Mapper and we're going to take a look at the pixels to points tool. So this is the Global Mapper interface for folks who aren't familiar with it. Over on the left, we have our control center, and that lists the layers of data that are loaded into the program. At the top, we've got menus and toolbars with access to the functionality of the program. And then our biggest rectangle here is our data view. And this is the top-down data view. I've got some geotagged images as well as a few ground control points. This is a subset of a larger image set collected by a member of our product management team here at Blue Marble. And I can grab my feature info tool, click on a single image. It will pop open in my default image viewer. And we can see that ground coverage polygon calculated from the EXIF information or metadata on that particular image projected here. So we can tell that we've got pretty good coverage. We've got a lot of overlap between these images, which makes it a great candidate for the pixels to points process. So I'll go ahead and close that, and I'll open the pixels to points tool dialog. Now, I've already loaded the images that I have in this workspace into this dialog. I've only got 39 here. Global Mapper can process very small image sets or very large image sets with the pixels to points tool. And I can choose to add ground control points here, because if I look at a particular image, I can zoom in on our preview and we can see we've got this ground control target. So I'll click to add my ground control points. I've already done a little bit of work here. I've worked with ground control point 2 here is the name of the point. And I can see that I have automatically placed this ground control point based on some definitions that I've made. Blue listed images here are places where this ground control point has been confirmed. And this image in particular is where I've defined this ground control. The way that is done is by choosing to define the target in an image. I'm going to zoom to that target with my mouse wheel, click and drag to say, this is what my ground control point looks like. And Global Mapper will go through and find that in all of these other images and place the point there. Now, if I take a look at one of these images, I can zoom out and see that I've got ground control point 2 over here on the edge. But if you'll notice more towards the center of the image, I have another ground control point 4. Now, this automatic placement tool has handled situations for me where there are multiple ground control points represented in a single image. Again, based on those image coverage polygons, sort of roughly projecting the image into that space, and then the coordinate location of the ground control point. Global Mapper does a really good job handling these situations where I may have multiple ground control points represented in a single image. You'll also note that in this data set, I'm using these high visibility man-made targets. These are great for easily being able to identify these control points in images manually, but Global Mapper and this automatic ground control point placement routine works just as well with natural features that you may have surveyed to use as ground control points, whether that is you know, a signpost, whether that is the intersection of some line features on some pavement. You're able to identify those using that same define target method, and Global Mapper will go through and automatically place those ground control points on any defined target. So you don't need to have these high visibility targets. You can use natural features in the scene. This just happens to be the data set I had on hand for our little demonstration today. So once I go through and I define each target and I place the images, I can double check that these control points are indeed placed in the right locations on the center of target number 2. I'll go through and confirm all of those placements. I'd be ready to run the Pixels to Points tool. Now, the primary output from this tool is a generated point cloud, but we also have options to generate an ortho image or a 3D mesh or 3D model. That's going to be a textured 3D mesh, so it will be the structure derived from the point cloud and structure from motion process, and then texture applied from our source images. Additional options on the other side of the dialog include some image reduction. If you're working on maybe a smaller machine with less memory and a very large image set, you might need to do a little downsampling there so that the process can run in full. And then some options to, you know, balance color if you have some shadowing maybe on half of your flight, or, you know, other color corrections that are needed. I'm not going to run this process right now. You know, with 39 images, it only takes a few minutes here, but we don't need to sit and wait for something to process during this session. I can go ahead and show the generated point cloud and image that was produced from the Pixels to Points process. So we'll start with the image here, since we're looking at our top-down view. And we can see, I'm zooming in pretty far, and we've got a good resolution here. We've got a very fine resolution image. Features are well represented. Of course, we're seeing some fragmenting as we get into some trees that were probably blowing in the wind a little bit on this day. You know, a water area that doesn't reconstruct fairly well. That's a common problem with this process of creating a point cloud across all softwares that do this analysis. And then, of course, towards the edge of the image, where we have fewer images covering a designated spot, we've got some fragmenting as well. We can also take a look at the point cloud. It is colored with the RGB values from the image. I can open the 3D viewer as well and take a look at this data in 3D. We can see we've got cars pretty well defined. These bright spots are some chairs down by the waterfront. We've got the faces of some included buildings, and then, you know, a crane structure, I believe, in the center for some construction in the area. So this is a very dense point cloud. We can see that by looking in the 3D viewer. We've got great representation of the ground and some of those ground features. And so, you know, additional tools in Global Mapper can be used for further analysis. Now, I can look at the metadata for this point cloud as well, and that's going to show me the point count and the point density. So we've got 950 points per meter squared. That's a very dense point cloud. You know, this Pixels to Points tool gives you probably more data than you need as an output. We have methods in Global Mapper, say the LiDAR thinning tool, to thin out this point cloud, and this creates a new layer that has many fewer points. This is, you know, under 500,000 points. They're just about 500,000 points. So we've decreased the size of this data, but retained some of that structure. So with that, I will hop back to the PowerPoint and we'll talk a little bit about another point cloud tool in Global Mapper, not creating data, but adding meaning to it with point cloud classification. Now, a key point of point cloud classification in Global Mapper Pro is geometric segmentation. And so this is a spectral partitioning of 3D points based on the attributes of those points. So depending on the method used to create or collect the point clouds can have many different attributes. Of course, there's going to be position, so X, Y, and Z for every point. Sometimes point clouds, like created from pixels to points, have an RGB color value. An intensity value, perhaps. True LiDAR collected data is going to have a return number, varying based on the sensor that was used to collect the data. And then some more shape-based statistics can be calculated, like curvature and normal of these specific points. The geometric segmentation process can take all of those into account and work to identify unique objects in the point cloud. We can see that in the screenshot here, where we've got those roofs and many different trees identified pretty clearly by segment. Now, this process is used in the classification process when we're identifying, classes of features, but it also is available to users to sort of hack for a custom use, to identify features that maybe aren't part of a built-in classification, and that can in turn be used to create a custom classification. So the dedicated segmentation tool in Global Mapper has options to customize what attributes of the point cloud are being used in the analysis, and then work to identify unique objects based on that. The next step, using some of that segmentation, is the semantic segmentation, and that is applying meaning to our identified segments based on that geometric segmentation. So this compares each segment, the shape of it and the statistics of it, to our class definitions. So each class, whether it's ground, buildings, vegetation, has a general definition of what a segment of points representing ground typically looks like. Like, fairly flat, not too much rapid elevation change over a small neighborhood area, versus a building, which is going to be, larger, maybe some pitching of a roof, and some different statistics associated with that. Built-in classes that ship with Global Mapper and are available in Global Mapper Pro identify some common features in a point cloud. So automatic identification of ground, buildings, vegetations, power lines, which with some of those finer features requires a little bit higher density in data. Poles, whether that's power poles, signposts, flag poles, or any of that vertical cylindrical feature. And then we also have a tool here to identify model key points. Now, model key points can be applied as a class, or they can be applied as a flag. And that is another way to essentially decimate your point cloud and maybe create a tin layer from it by analyzing the point cloud to do a really good job retaining the structure of it while reducing the overall point count and file size. This is a really key tool for folks who are maybe taking a point cloud and creating a vector tin layer, or want to cut down set of points to bring into an engineering application like a CAD application, which maybe doesn't handle large, dense point clouds as well as a dedicated geospatial application. Now, based on the geometric segmentation and some of our semantic segmentation, we have the opportunity in Global Mapper Pro to train a custom classification. Now, I mentioned all of the built-in classifications Global Mapper has, but training a custom classification allows the user to pick out features in the point cloud that are distinct and can be identified with the geometric segmentation, and collect a sample of those points, calculate some statistics to create the fingerprint or the profile for that specific custom class. That custom class can then be used to classify features in that point cloud, additional point clouds, and it can also be exported, saved to a file to be shared with other Global Mapper users. So you can create a whole library of custom classes for maybe some more niche objects that you are looking for in your data. So I'm going to jump back into a Global Mapper workspace. This is a slightly different one, and we'll take a look at some of the interfaces for this point cloud classification and segmentation. So I've got this area of data. This is a golf course with some water running through it. And I've applied some classification here in Global Mapper already. We've got buildings in orange, ground in brown, and vegetation in green here, some little spots of water in blue that I did some manual classification on. And flipping back to our RGB visualization, this drop down here gives us the opportunity to view our point cloud by any different numeric statistic that we may have. So classification, return number, elevation is another common visualization, and then a color value if we have one. We can see in this visualization we've got some sand traps that are a fairly distinct color, and we might want to pull out into a custom class either to do some feature extraction or to further analyze these specific areas of the point cloud. So for this, I can pull up the geometric segmentation tool, and this is the interface where we can customize the attributes and the weight of each attribute, how it's considered in the analysis. This helps to identify points that are likely part of the same object, and then based on how closely they are connected and how closely some of these statistics are, they are broken into segments. The results of this tool run on a small portion of this data set. See, I can change my visualization to color by segment, and we can see the sand areas pretty clearly defined. Now, if I want to create a custom class for these sand areas, I can come up and open my automatic point cloud analysis tool. Opens as a new tab docked to the side here. And we have our built-in classes represented: ground, building, power line, vegetation, etc. But we also have the option to enable custom feature models. So this pops open a floating dialog where I can collect my sample data because I need to tell Global Mapper what I'm trying to classify. I will add a new class. We will call it a sand trap class. And this will be a sub-classification of ground, since those sand traps right now are classified as ground, and realistically they are ground. I can then use a segment select mode, since I have these identified by these brightly colored segments, and just select the areas that are sand in this segmented section of the point cloud. I'll collect the sample. Global Mapper is going to go through and combine the statistics of these samples that I have selected. I can then apply those to a class, my custom sand trap class. Now that I've selected this from the dropdown, I come over to our main dialog. We can see that we don't have a signature defined quite yet for these, but I can click train, and Global Mapper ports some of those collected sample values into my custom class. I can then save this to a file. If someone had shared a custom class with me, I could load a new custom class. And we can see down in our classification section, we now have the option to classify sand traps. So the result of classification of those sand traps is going to give us a point cloud that has ground, buildings, vegetation, water identified, and then in this light orange color, we have our sand trap areas. So of course the areas that we used for training, but then some additional sand area along the water's edge here. And it gives us a little bit more meaning to the point cloud. Additionally, in Global Mapper, there are many tools for visualizing this point cloud. We can take a look at that cross-sectional view, maybe across one of these sand trap features, and see that it is very similar to ground in shape. But we are now looking at sort of a cutaway version of this point cloud. The filter LiDAR data tool in Global Mapper is another great one when you're working with point clouds. It simply allows you to filter out point cloud classes that you may want to see. So, maybe I want to hide all of my water classified points. I can click there. We've got those water points hidden, still get some unclassified points in this area. I can hide those as well. So I'm only looking at the points that have been given meaning by some of these analysis processes in Global Mapper. So I'll pop back to the PowerPoint at this point, and we'll talk a little bit about maybe the next steps with a data set like this, which is terrain creation and terrain analysis. Now in Global Mapper, you can of course load terrain from any supported file format, but you can also create it from point clouds and other 3D data in the Global Mapper program. And then once you have a terrain or digital elevation model in the Global Mapper interface, you can do all sorts of visualization and analysis for it. So we've got terrain creation, again, from 3D data, whether that's a point cloud or vector data, or the combination of both with a little bit of flattening based on maybe some vector areas or break lines. Within this terrain creation tool, we can create the digital elevation model that we're seeing in the screenshot, in 2D and 3D view. This one was generated from a point cloud that I filtered to only utilize those ground classified points. So it's removing, the big building that's in that flattened area. But through the terrain creation tool, you can also create a vector tin layer. So creating a tin from all of the points in the point cloud, a very, sometimes very, very dense vector feature that has many different tin faces, sort of finely defining the shape of the point cloud in a vector format. And of course, that can be exported to any supported file format in Global Mapper. Moving on to some terrain analysis, once you've got your terrain layer either loaded from a file or created in Global Mapper, this is just a small sample of the terrain analysis tools that Global Mapper offers. Of course, there is contour creation. That's probably one of the most used terrain analysis tools in Global Mapper, creating some contour lines to define the elevation with some vector line features. We also have break line extraction. That is going to find break lines within a terrain data set, whether those are tracing along the edge of some flattened areas or just finding and creating lines at any place where there is a sudden elevation change or a large curvature. You can do manual terrain editing with the terrain painting. So whether that's smoothing the terrain, whether that's filling gaps in the terrain with some interpolation, if you've got holes in your terrain model, the terrain painting tool allows you to basically use your cursor as a paintbrush and change the elevation values in your terrain layer. Volume calculations and flattened site plan creation are some other terrain editing methods, and that's what we're seeing in our screenshot here, where I've taken a site polygon and chosen to flatten the interior area, sloping from our flattened elevation out to the existing terrain. All of that editing is contained within this polygon feature, and it allows me to then maybe perform a volume calculation to see, to create this flattened pad for a building or other feature, how much, what's the lift going to be, how much effort is going to be put into the earthworks part of this project. A new tool in Global Mapper 26 is a solar shadow analysis. So that brings in some terrain analysis, incorporates 3D vector features where you have them, and calculates the shadow at a given time for a given area. So we can take a look at the sun exposure, whether that's for environmental applications or energy applications, maybe the placement of a field of solar panels. There's also vectorization, so you can manually create vector features from the terrain data by drawing those vector features manually and then applying some elevations to them, or extracting polygons that represent certain elevation values or certain slope values. There's many, many more terrain analysis tools in Global Mapper, things like viewshed analysis, line of sight analysis, watershed, flood simulation. So, many options in Global Mapper. We keep trying to add new tools to all of these tool sets based largely on some user requests and what folks in different industries need from a geospatial software. I will once again pop over into the workspace we were just working in with our classified point cloud now. And I can see that I've got ground, buildings, vegetation represented, and I'll close this automatic point cloud analysis tool. We're done with that section of the workflow. And I can create some terrain here. Now I also have a polygon representing the water area in this, this golf course. So using the feature info tool, I can view all of the attributes for this area, including the elevation. So this is showing us the water level of this particular area. Now, if I enable both the point cloud and my water polygon, I can come up to the analysis toolbar in Global Mapper and create an elevation grid. I'm going to create a digital terrain model, or DTM in this case, and to do that, I'm using both that water polygon and the classified point cloud, and I'm going to choose to filter that point cloud. So right in this terrain creation tool, I can filter my point cloud to only use our ground, and I also need to include our custom sand trap classification. Because those sand traps are part of the ground, and we want to include that in the generated grid. This slider here controls how far across gaps in the data Global Mapper will interpolate. So that would be, across areas of dense vegetation where there are fewer ground points, or where there is a building and there are no ground points. And I will be using my 3D area as a break line, and it will flatten the interior of that polygon to our defined water level. So I will go ahead and click OK here. Global Mapper, with this small data set, quite quickly generates our terrain. So we can see this is shaded by elevation, our flattened water area here, and we can see that the buildings have been removed. We've got some holes where those buildings were, and our interpolation setting wasn't quite high enough. But we can repair those either by generating a new terrain grid and just increasing the no distance data criteria for how far the program is going to interpolate over some gaps in the data. Or I can use the manual terrain painting tool to essentially accomplish the same thing by just filling in these gaps. So there are many different options for editing the terrain here. Filling gaps is probably one of the most basic. We also have an option to smooth the terrain based on a local box size average. There are options to slope the terrain along or across a line, set the terrain height to a specific height or elevation value, and then raise or lower the terrain by a specific increment. Now, this isn't done to the whole layer at once. Typically, we have these brush types that are similar to our digitizer vector feature creation options that you might see up here, where I can choose to use an area trace mode to fill gaps, and I'm just going to click and drag my cursor around some gaps in the data, and Global Mapper is going to fill those in. So a powerful tool here for manual terrain editing that gives you quite a few different options on how to manipulate the values in your elevation model. From here, I mentioned that we're looking at this data shaded by elevation. We're seeing a lot of texture on this data and some shadowing because we've applied a light source to it through hill shading. I can turn that off, and now we're just looking at those raw elevation values. We can also change the lighting effect that's added, linking that to a specific date and time for this particular area. where this data set lies, or by manually moving that light source around. There are some other visualization parameters here as well for changing how that light is applied, maybe bring out some different textures and different finer features in your generated terrain grid. There's also the option here to change the shader. So currently we're using a blue to red elevation shader. There's not too much elevation change in this particular area, but we have options to shade this data by slope as well. So now we can see the darker areas are where there is a higher rate of elevation change, a steeper slope. This can be used to do some of that extraction that I mentioned, that vectorization of maybe high slope areas, those very steep areas, or conversely, very flat areas. There's a whole bunch of different shader options, along with the option to add a custom shader. So custom define the colors you want to use to display your data. So not only very powerful with the processing in Global Mapper here, but with the visualization. Now I can create some contours really easily with this data set. I've just grabbed my contour creation tool. Again, not so much elevation change in this data set, so we won't get too many line features, but taking a look at that, we've got 3D line features now defining our area. We can see that there's no contour lines crossing our flattened water area, and then along the banks is probably where we've got the steepest slope, and then some hills as we get to the edge of the data set. Again, the path profile tool can be used to take a cross section and look at this data. Right now this data is being shaded with our applied shader, but we can change this to maybe a different shader in this cross-sectional view, or just a solid filled terrain color. Additionally, an option for this tool is enabled where we're seeing vector area and line features that cross our terrain. So we're seeing where those contour lines are, sort of some guidelines for our elevation. Next, we'll look at some deep learning and image analysis with the Insight and Learning Engine, the newest addition to Global Mapper, as we wrap up here. So, as I mentioned, there are 3 models built into the Insight and Learning Engine. There are 2 for object detection, a model for building identification and vehicle identification, and then a model for classification, and that would be land cover classification. The way this works is you would take high resolution input aerial imagery. The deep learning model would run the process on it as you tell it to. And for buildings, as an example here that we're seeing with our screenshots, we're going to get vector building outputs. So some vector features showing where those buildings are, as well as a raster masked output that's going to just show 2 colors, 0 or 1 for no building, or yes, there's a building there. Vehicle detection isn't going to create these 2 layers. It's just going to create bounding boxes around the vehicles that are detected in the image. And then land classification is going to create a raster palette image output with the palette colors representing all the different classes identified in that area. So Global Mapper, with this Insight and Learning Engine, you can use the built-in models, but the next step would be a fine-tuning or retraining process that would help to adapt the model to the data that you're specifically using. Generally with raster data, there's just so much, well, with any data really, there's so much room for variation, whether that's the image sensor, whether that is the resolution, the natural area, different areas of the world look widely different. So being able to create some ground truth data, sort of run some inference, get those initial results from the built-in model for, say, building detection, and then run some fine tuning that says, all right, let me adjust what the model is seeing as a building, and do a little bit of retraining, help teach the model, this is what buildings look like in the area, and then, run that custom fine-tune adapted model to get some better results from this process. So quickly here, I will show a little bit of these insight and learning engine tools. I've got a tile of high resolution imagery here, and these tools will be found on our small little deep learning toolbar. So we've got object detection, where we have tabs for our building extraction, vehicle detection, and then any custom trained models. So for this, I would have had to, do some fine tuning and have a custom model in my instance of Global Mapper in order to have some options here. Building extraction allows us to, use some aerial imagery, apply some post-processing to help clean up the polygons of the building. And the result of that is going to be, again, 2 layers. We've got our building footprints as a raster, and then our vectorized building footprints here. Turn up the imagery so we can see those outlines a little more clearly. So that's one of our object detection methods. The other is going to be vehicle detection. Here, the result of that tool is going to be bounding boxes around any identified vehicle. So here we see these yellow bounding boxes with this. These are our vector features. So right in our control center, we're going to get a count of how many features we have here, how many vehicles were detected in this particular image. The fine tuning or create model interface is going to allow us to generate some training data. So using some tools in Global Mapper to identify, this is a building, this is a vehicle, or a particular land cover type, and then edit or adapt any of the given models that we have here, whether that's building extraction or our land cover. So a very powerful tool for raster data processing, so automating some of maybe manual work for identifying vehicles in an area, or classifying land cover based on high resolution imagery. A very powerful model, again, deep learning based, and we're always looking to expand the tools in Global Mapper, and this is our latest effort towards that, expanding our image analysis tools here. So as we wrap up, I just want to mention I've scratched the surface on what Global Mapper does. There are many other tools. We didn't talk much about vector data creation, editing, and analysis, attribute management, but Global Mapper has tools for all of that, as well as some additional raster analysis tools with manual raster image editing, with the raster painting tool, which is very similar to the terrain painting tool we looked at. There's raster calculation for calculating, values from aerial imagery like NDVI and some other indices like that. And then vectorization. I mentioned that for terrain data. It's also available in some raster data, so pulling out features from raster data or tracing features in raster data. Global Mapper also supports Python as well as a text-based proprietary Global Mapper script, and many of the different routines in Global Mapper can be scripted. So to optimize the workflow, if you're running a similar process on many data sets or many tiles of data, you can write or create a script that will do some of that for you, so you're not waiting for things to load and interacting with the UI quite as much when that's not necessarily needed. Global Mapper does so much, and I'm right towards the end of our time here, but I just wanted to mention a few more tools. I think we have a few minutes for questions, and I definitely encourage you, if you're not a Global Mapper user and you want to go check it out, our website's on screen, bluemarblegeo.com, and you can download a free trial of Global Mapper, check it out, load some of your data in, and see what the program can do for you. And I think that we have a few minutes for questions, and I just want to thank everyone for being here and for listening and being interested in Global Mapper.
Oh, wow. You said you scratched the surface. Wow. And learning from it is excellent, Mackenzie, and thank you so much for your presentation. Yes, and you said now we have the QA session. Remember, you still have time just to leave your question or comment in the question section, either in English or Spanish. Indeed, we have some questions here. Let's go in one order. Gabriel Cedeño asks, one of the advantages of Global Mapper is the ability to quickly manipulate image. Do you think that the processing is faster than other software on the market?
The processing, I think we're compatible with other softwares on the market. A lot of the processing done in Global Mapper is tied, like the processing speed is tied to the hardware that you have available. The amount of memory affects how much data you can load and how much data you can process at a time. We try to be as efficient as possible in our development there. And then, you know, many processes, a lot of the advanced analysis for sure is multi-threaded in Global Mapper. So if you have a higher level processor or maybe even some GPU processing capabilities in your machine, you're going to be able to do more and do more quickly in the program. So I know that's not a very great, clear answer, but it is, you know, highly hardware dependent, as you know, a lot of software is these days.
All right. Professor Iliani Arenas just asked, do you have license for educational and research purpose for universities, public center or institute?
Yes, so we do have an academic program where we provide some discounts to licensing in certain areas for, you know, teaching with Global Mapper. You know, we want to get more people using it, and we want more people to understand geospatial data and how to work with it. So we do have some opportunities for academic licensing, and you can find those on our website as well. We also have an academic curriculum which comes with, I think, 10 or 12 labs that have step-by-step workflows and then some more open-ended, you know, questions for students to go through and use the skills that they have acquired through that workflow to, you know, further their learning of geospatial data. So if you're interested in using, you know, Global Mapper at an accredited university or teaching with it, then, you know, please reach out to us and we can give you more information about how to go about doing that.
All right. So, well, the next question is how to the procedure to follow, but you mentioned in the webpage. Okay. Antonio Marque asks, can you generate a model just based on the return number to have the true DTM?
So just based on the return number, I'm gonna pop over to Global Mapper workspace here to quickly show that we have, you know, visualization by return number for sure, so we can see that. We also, in the filtering option, have a filter by return type. So we can do, you know, a single return, we can filter to a first return, or let's filter to a single return. And now we're looking at only our single returns. So this is still capturing those building roofs, but, you know, we're filtering by return. We could also filter by classification. And when I go to create my terrain with this terrain creation tool, of course, there's the filtering right in there that has all those same options, but Global Mapper as a base is going to work with the data that you have displayed. So right now, we're only going to be looking at our single returns with the water and unclassified points filtered out. So yes, there is definitely a way to do that filtering and create, you know, that terrain model based on only the points you want to consider.
Excellent. Also, Gabriel Cedeño, are there some improvements in the visualization of point clouds in such intensity with the color?
Yes, so that's a great question. I'm gonna just bring back all my points here. And we can view this point cloud by intensity. If I go into the point cloud options here, we can view by intensity and, you know, make that brighter or dimmer based on some of our grayscale options. We can also use a specific built-in color ramp, a shader here, to visualize that intensity. So here I'm using that blue as a low, red as a high, and this is still intensity being visualized. We've just got more color, which, you know, helps to catch maybe some of those nuances that you don't see in the gradient.
Okay. Next question, Darío González. Excellent presentation. How does Global Mapper support mobile data collection and integration with Global Mapper Mobile?
Yes, so Global Mapper Mobile is an iOS and Android app for mobile data collection. And that's a great question. I'm glad that you brought up that product because it is one that I work on as well. And Global Mapper has an export to Global Mapper mobile package format, which will package up raster, vector, point cloud, terrain data all into one file that is efficiently compressed, and you can share that to a mobile device. Now, in the Global Mapper program, we have the mobile data management tool, which allows you to do a wireless transfer to your mobile device if it is nearby and connected to the same network, or you can use a shared drive or email that file. Bringing data back from Global Mapper Mobile is the same process, so you can, pull that data into Global Mapper by emailing it or using a shared drive like Google Drive or Dropbox to move those files from one device to another. Global Mapper also has tools for some data merging. So once you've done your data collection in the field, you've saved that new version of your map on your mobile device, shared it back to your source controller, your computer. You can bring in and say, all right, what features have I edited? What features have I changed? And explore those changes, choose the version that you would like to keep. This is particularly useful if maybe you're the person in the office and you're sending this data out for different field collectors to do that data collection, and you're trying to bring it all back in and combine it in Global Mapper. So there are definitely tools for working with that. And if you have more questions about Global Mapper Mobile, again, I'd encourage you to reach out to us. We're always happy to give advice and help on those things. And you can download the app for free and then test it out as well.
Yeah, sure, we will. Well, there are no more questions in the panel, but I have a question, not a technical question, but how do you consider is the penetration of Global Mapper in the Latin American countries and communities?
So we do offer Global Mapper in different languages. We do have a Spanish version of Global Mapper. So we do try to, bring the program to as many places as we can. We don't have, at least I don't have too much, experience presenting in Latin American countries, and I don't know the specific statistics on what we're doing for business down there. That's not my department, but we definitely try to, support as many people as possible. We will get sometimes technical support emails that are in different languages, and we do our best to answer those, even though, we are based in Maine and are mostly, primary English speakers. We do also have a reseller network that has, reselling partners that work with different languages around the world, and including some in South America. So we definitely try to bring Global Mapper everywhere. We are doing global business, and we're always trying to expand that, because being based in the US, sometimes we do get stuck in that mentality of US, and we need to consider the larger world.
Okay, that's fine. Well, no further questions, so I would like to thank you, Mackenzie Mill, for the time and assistance with this webinar, and I would like to present you with this certificate. I don't know if you can see my screen.
Oh, great, thank you.
Okay, I will send you. You are honored that my signature is there. As a member of the SIGGMA board. So again, on behalf of the organizing committee, I'd like to thank you, everyone who joined today, and we hope you found beneficial and valuable this information. Mackenzie, Jessica, don't disconnect. We are going to switch back to Spanish to get some information, and then after the closing session, we will have some words. De regreso a español. El próximo webinar dentro de las terceras jornadas de Ingeniería Geodésica Aplicada está programado para mañana sábado 12 de octubre a las 5 p.m. hora de Venezuela, y tratará sobre el monitoreo automatizado de deformaciones en excavaciones subterráneas, un método innovador para ingenieros geotécnicos, por parte de Carlos González, Esta sesión será en español a través de nuestro canal SIGGMA en YouTube. Para más información, favor visitar nuestras plataformas de redes sociales bajo @SIGGMAXYZ, Sigma con doble G. Esto es todo por hoy. Ha sido un gran placer haberlo servido. Gracias de nuevo por su atención. Se me cuidan y nos vemos mañana. Dios mediante. Chao.